And now we're going to move on to the first talk of the session, and that is by John Keller, and he's going to be talking to us about the Lunar Reconnaissance Orbiter results and looking forward. Thank you, John.
Thank you. Is this a pointer? Awesome. Okay. Let's see. How do I start it? Okay, no, this is fine. I just need to get it started. Yeah, so I'm glad to be here. We titled the talk as Lunar Reconnaissance Orbiter Looking Forward, but I also want to take a little bit of time to look back. Let's see, I'm not sure what happened there, so. You know, when preparing the talk, I thought that, you know, LRO is just completed its 5th anniversary in orbit, and I know that we were also before launch at the first of the NLSI forums in 2008, and I looked at those talks, and in that we talked about the instruments and what their capabilities were. We have 7 instruments on board LRO, and I found that you know, that we've largely all of those instruments worked as planned and as promised, and we've been delivering data to the planetary data system since launch. We went into a commissioning orbit, and eventually into our mapping orbit in September. And we started off the mission in the ESND phase, and ESND program, Exploration Systems Mission Directorate, and Mike Wargo was our program scientist, and without whom, you know, really, I'm not sure that this mission would have happened. He was a tremendous advocate for LRO headquarters, and was involved in the creation of the mission. We began our science phase, and we went from the SND mission in September of 2010, and have been there ever since. And we are currently in an extended mission to be completed at the end of September, and we have proposed a We have proposed an second extended mission, and still waiting to hear the outcome of that proposal. There should be a video here. This was one of the first images. You know, looking back, one of the first images that came back from LRO. It's the rim of Shackleton Crater. It really, when we saw it for the first time, it was incredibly exciting to see the moon so close up. This camera gave us 50 centimeters per pixel resolution. Huge amount of data that's been returned. At this point, we have about 70% of the moon at this resolution, or very close to it. We're spending a lot of time doing a lot of repeat coverage as well. Let's see, do I still have control here, or? Okay. And these are the themes for the second extended science mission. Transport of volatiles is something that has already been talked about. It's very exciting. Paul Sputis talked a little bit about it. And, you know, really, taking from Paul's talk, I think LRO is kind of a mission that took the baton from Clementine and Lunar Prospector and is moving forward. Contemporary surface change. One of the tools that's come out of the LRO mission is the ability to see things that are happening during the time that LRO is up there, and In particular, I'm referring to impacts, and I'll say a little bit more about that. Regolith evolution, probing the interior from observations of the surface, and interactions with the space environment. And I don't really have time to go into all of these, so I'm just going to take a small selection. Next slide. A little more of our history, the orbit history. We moved. Our mapping mission was very much a circular, 50-kilometer orbit. But after a period of time, it was an expensive orbit to maintain, and so we went back into what was our commissioning orbit, and that's where we are today. These changes are station keepings that we have to do periodically. So now we have a periapsis around below 50 kilometers over the South Pole. We're getting high-resolution measurements over the South Pole and continue to do so. So on the next slide, one of the really exciting results from the LRO mission is the ability to look at contemporary surface changes I mentioned. And here is an example where March of last year, from Ames Research Center, they observed a flash on the moon. We were able to go back and find the LROC team, the camera team was able to go back and find that crater that was created. And the fortuitous thing is we had data prior to the impact, and so the only way we can really see these things, because there's a lot of fresh craters on the moon, is by blinking between post impact and pre-impact. And this is a fantastic new tool for studying impacts. I think one of the outcomes of this, or one of the observations, was that from this impact, which is a meter scale impactor, was able to throw up material that was found as far as 35 kilometers away. And that's really unprecedented, and I think it's a way it allows us now to really look for more of these recent impacts and study them in a way that hasn't been done before. Now, similar things can be done on Mars, and is being done on Mars, but the very difference, the fact that there's no atmosphere on the moon, it makes it fundamentally different in the way you're able to study it. Another example of a impact that was observed from Earth, next slide, I guess I've lost control here, is this one was observed from Spain. And this is an even larger impact. It turned out to be about a 36 meter crater that was observed. So on the next slide, what I want to talk about here is another one of our themes, and that's the transport of volatiles. And I'm picking this one because it's one that really all of our instruments contribute to, and is really it's part of, again, our extended mission. And so one of the very fascinating observations that we've made with using a diviner, the temperature measurements on the moon, and LOLA, the laser altimeter reflections, not the measurements of the topography of the moon, but the reflectivity from the laser. And so what is observed here is that you see that the reflectivity has become somewhat brighter as a function of time of day, and that's a hint that there may be some transport taking place of something that is brighter, possibly water frost. And then you see the brightness on the lower slide here, the brightness of the rising up as the temperature as measured by diviner, it goes into even lower. And so that again is another hint. And then just looking here at these South Pole craters on the next slide, again you see that over those craters, diviner temperature versus reflectivity, you see that increase in the pulse, and that's an indication, we think, possibly of water frost. Next slide. Another example that is very intriguing from the LRO mission is the neutron measurements, where we see indications that the neutron albedo is measured in as a signature of water, is also time of day dependent, and this will be talked about later in the meeting. So I won't say any more about that now. On the next slide, another example from the LAMP instrument. This is the UV imaging spectrometer, where we're seeing from reflectivity of far UV light an indication of transport of water as well. And so we're seeing in far UV what has been observed in infrared by the M-Cube mission. And basically what you're seeing here is this is on band where the UV is sensitive to water, off band where it is not sensitive to water, and you can see that this is beta angle, essentially equivalent to time of day, so that high noon you can see a clear signature of a change as a function of beta angle in the UV. So on the next slide, the one instrument that isn't represented at this meeting is the Crater instrument. So I wanted to talk a little bit about that, about this instrument and some of its results. And it's concerned with the radiation environment at the moon. And it's a energetic particle telescope. It's got 3 sets of detectors, and sandwiched between them is tissue equivalent plastic. And so very energetic particles will travel through the whole telescope, and the energy deposited into the detector is what is measured. So here on the right, you see this two-dimensional histogram, and what that is a measurement of one of the outer detectors against the inner detector. And so if a particle registers on that histogram on this 45-degree angle, what that means is the particle went through and didn't lose much energy in the tissue equivalent plastic. However, when you get to see some of these tracks on the heavier particles, what that means now is that that this is an indication that the tissue equivalent plastic is now absorbing that radiation and absorbing that energy. But also important and of extreme interest is the fact that these columns of detections here under the heavy atoms, and what that represents is what has happened is the particle has gone through the first detector, and then as it's in the tissue equivalent plastic, it's breaking up. So it's turning from iron into other atoms. So I'm running out of time, it looks like, so I'm going to move on to the next slide. And I'll move on to the next as well. I wanted to talk a little bit about the data that we've delivered to the planetary data system. And this is an advertisement for the community, you, to use that data. So on the next slide, this was an example from the literature that people are using our data. This is using the photometric functions as observed by the LROC cameras to draw inferences on the regolith of the lunar surface. Next slide. Data is also serving the survey teams. And here's an example from Ben Bussey's team on volatiles, where they've looked at the existence of permanently shallow areas at lower latitude and have found them using the LOLA topography and LROC topography as well. And what's kind of interesting to me is that if the next mission to the moon is a South Pole Aiken sample return, we'd all like to see that, but there are permanently shadowed areas there, so we can get a dual benefit from a mission such as that. The rover, if there is one, could slide up to that PSR and take some samples from there as well as other places. Next slide is another example of surveying the survey teams. I didn't know Simone was going to give the talk prior to this, but this is from one of their papers, and this is use of the LOLA data to look at cratering in ancient lunar terrain, and derive inferences and conclusions based on really one of the most important questions for lunar and solar system science, and that is the lunar cataclysm. On the next slide, I just wanted to make again an advertisement that the Lunar Data Analysis Program, Step 1, is due at the end of next month. That Step 1 is no longer a notice of intent. It is required, so make sure that if you want to do the lunar data analysis from LRO or any of these other missions, make sure you get that in. Finally, this is a last so we're revisiting Apollo 11 from LRO. Really just probably 20 minutes ago and 45 years ago, Apollo 11 lifted off from the moon. And this is the landing site as observed by LRO using a wonderful LROC data set. We're able to get the three-dimensional alignment. Thank you.
That's wonderful. Great talk. We have time for a few questions, so anybody have a question they want to ask now? If not, we are going to save some time here and move on. There's one, Jack. Go ahead.
What does Buzz Aldrin say? Does Buzz Aldrin see that? And if so, what does he say about it?
You know, it was just released, so I don't know. I hope he likes it.
It'd be great if you could get him to narrate it.
Yeah. Yeah.
Any other comments or questions? No? Okay. Thank you so much, John. Really appreciate that.